Hello friends, so in this session now we will understand how can we verify any given bilateral network and we can convert into its Thevenin's equivalent circuit. So in this operation here we will understand that in our Thevenin's theorem any given bilateral network that here you can see we can convert into its Thevenin's equivalent circuit in which it is connecting a Thevenin's resistance RTH along with load resistance RL and Thevenin's voltage VTH. So here we are having following steps that here we need to identify. So first of all, in Thevenin's equivalent circuit we have two parameters like VTH and RTH. So the condition for finding RTH is that a voltage source we need to keep short circuit, or if any current source is given, so we will keep open circuit. For finding RTH operation we need to follow this operation. After that RTH we will find out VTH by considering load resistance as open circuit. So in this given circuit, now here we are considering R4 is load resistance. Means here we will identify our output current in this load resistance. So we will design this circuit and our equivalent circuit we will identify it by the following process. So now here we are going towards our simulation tool. So for this operation, let's we are designing on Tinkercad platform. So according to the given circuit, we are taking our breadboard. You can see, since it is working on DC supply voltage, so we will consider a 9 volt. So here we can rotate it and we can connect accordingly. So we are taking 4 resistance. So as per the circuit diagram, we will design. So now here this is our resistance R1. So I will connect on resistance R1. Now the second one we have resistance R2. So this is your resistance R2. Next resistance, that is your R3. So I will connect R3 over there, and load resistance R4. Okay, so our configuration is like that. Our positive terminals of this battery is connected to the first terminal of resistance R1. So I will connect accordingly. So in the breadboard, this part is vertically shorted and this plate is horizontally shorted. So by keeping in this way, we will design. Now we will connect negative polarity with the connection of resistance R2 and R4. Okay. So now here, what is that? It is your R1, it is your R2, it is your R3, and it is R4. Now we will follow our first step. So in the first step, we need to keep our given voltage source to be short circuited. So for this operation, firstly we will delete these two terminals and we will open our load resistance which is given as that is your RL. So we will mention that is your RL. So now here we will connect by taking a wire to the short circuited. So you may take any wire from here that it is your vertically shorted, so I can connect over there. And here from the load side, as you can see from the load side, now we have open circuited. So we will connect multimeter for observation of RTH. So here I will connect my first terminal to this terminal and next terminal from here to here. So this is your horizontally shorted, so you may connect anywhere. The property of this multimeter that you can find out voltage, current and resistance. So in this operation we are measuring the value of resistance. So here we will select resistance, and now here after selecting this we are having start simulation. So on start simulation it will give you the value of Thevenin's resistance RTH 1.5 kilo. So after noting down this value 1.5 kilo ohm, it is the RTH. Now our second step, we will find it out VTH. So for this operation, again we need to give our power supply. So I will remove this wire and I will connect my positive terminal to the first terminal of resistance R1 and negative terminal to the resistance of R2. Okay, so now here our circuit is ready. So we need to identify VTH across the open circuit terminals. Okay, so now we will change the terminal. So our parameter is voltage. So I will click on voltage and now we will start simulation. So after doing this one, now you will give VTH 4.50 volt. So we have found it out our two parameters VTH is equal to 4.5 volt and RTH 1.5 kilo ohm. Similarly, here as we have taken our all resistance as 1 kilo ohm that you can see. So after finding these parameters, now we are having the formula. Let's move towards our formula. So our formula is given, that is your ITH is equal to VTH divided by RTH plus RL. So here when you put your value, so you will get the value of ITH. So this is the formula, or you can see it is called load current towards the load resistance RL. So this is the analysis of Thevenin's theorem. Thank you.